Hello and welcome everybody to a little video explanation. Today I'm going to be talking you through the weekly exam question 1 solutions. I'll be running you through these every week just to kind of give you an idea of the sorts of questions you might want to prepare for the exam, as well as the thought processes that you might go through to answer these sorts of questions. So first up, we are trying to solve a question that involves a parallelogram. So whenever you're given a question like this, it really helps to draw a picture of the situation. So we've been told that we have 4 points, A, B, C, and D. Let's try and put these down in a Cartesian plane. So we have the point A, which is here. So that's 5, 14. That's A, 5, 14. We have somewhere over here in the negative quadrant, we have B, which is -1, 4. And then we have C, which is over here. So that is 4, 1, and we're trying to find the coordinate D. Now you may notice that 2 potential parallelograms could be formed based on these 3 points. The first one is if we consider these to be the sides like this. So we could get a parallelogram where those 2 sides are parallel to each other, those 2 sides are parallel to each other, or we could get a situation where we have a parallelogram that looks like this. And it's actually that second one that we're after here. The reason that that is the answer and the other one is not is because the way that this parallelogram is labeled is it's called ABCD, which means we're going to start at the point A, move to the point B, then C, then D. So it's forming this shape here. So that's telling us that the point D is just over here. So how can we answer this question? There's a few ways you can answer it, but the way that I'm going to show you here is we're going to come up with a particular realization, which is that given any parallelogram, the diagonals will intersect at the midpoint of each of those diagonals, which is to say that if we were to draw a line from B to D and draw a line from A to C, those 2 points are going to intersect one another at the midpoint of each of those 2 lines, which is to say that the line AC, or the midpoint of AC, is going to be equal to the midpoint of BD. Okay, so let's just set that up. Now remember, we do not know what the coordinates of D are, so I'm just going to call those coordinates XY, and we're going to try and solve for XY. So let's go ahead and set up that equation. So we're going to use the midpoint between 2 points equation, which is basically we take the average of the x coordinates, which in the case of AC are 5 and 4, so the 2x coordinates, so that's 5 plus 4 divided by 2, and then we're going to look at the average of the y coordinates, which is 14 and 1, so that's 14 plus 1 over 2. Now that needs to be equal to the average of the points between x and between B and C. So the x coordinate of B is 1, and the x coordinate of D is x, because we actually don't know what it is. And similarly, we have the y coordinate of B is 4, and the y coordinates of D is y, and we're trying to find what x and y are. Now, at this point, you can basically just treat this as 2 equations that we're trying to find x and y in. So if we were to, for example, try and solve x, we can see that 5 plus 4 divided by 2 needs to be equal to -1 plus x divided by 2. If you multiply both of those sides by 2 and then plus 1 to both sides, we're going to see that x is equal to 10. Similarly, if we were to try and solve for the y-coordinates by looking at the 2 y-coordinates of these 2 midpoints, we're going to see that we have 14 plus 1 over 2 is equal to 4 plus y over 2. Multiply both sides by 2 and then minus 4 from both sides. That's 15 minus 4. That's equal to 11. Okay, so therefore we can conclude that the coordinates of D must be 10, 11. Okay. So let's move on to question question 2. Question 2, we want to determine the midpoints of BC and AD. And AD. All right. And just to help us out here, I'm going to go back up here. I'm going to erase that XY coordinate for D. and I'm just going to label that on here as 10, 11. Okay. All right, so let's try and find those two midpoints. So let's start out with the midpoint of BC. So the midpoint of BC, that is once again the line that connects those 2 points, B and C. So to find that midpoint, we're going to find the average of the x coordinates, -1 plus 4 over 2, and the average of the y coordinates, which is 4 plus 1 over 2. We can see that that's equal to 3 over 2 and 5 over 2. Then we have the midpoint of AD, which is going to be the line from A to D, which are those 2 points there. We want to find the average of those two x coordinates, which is 5 plus 10 over 2 and 14 plus 11 over 2. And we can see that that simplifies down to 15 over 2, 25 over 2. Right, so we've got those two worked out for us now. Okay, moving on to question 3. So now we're trying to find the equation of a straight line. So we're trying to find the equation of the line AB. So equation of AB. Now, whenever we're trying to find the equation of a linear line or a linear equation, we need to choose one of those forms of a linear equation that we're going to use. So generally, we're going to be using either the gradient intercept form of a linear equation or the point gradient form of a linear equation. And these should be in your theory book. They'll also be given to you. Oh, no, I don't think they'll be given to you in the exam, so you'll need to know it. So the one that we're going to use here is the point gradient form of a linear line, which is y minus y1 is equal to mx minus x1. That m there is the gradient of AB, and what we've called x1, y1, that's just going to be the coordinates of one of those 2 points, A or B. So let's say we just call that A. So let's say we're going to use the coordinates of A in this line. So that's the one that we need to use. So very first thing we need to do here is find the gradient of AB. To do that, we're going to use rise over run. So that's the difference between the y coordinates divided by the difference between the x coordinates, yeah? So let's go ahead and do that. So the y coordinate of B is 4, so that's 4 minus 14 over -1 minus 5. So that's going to give us -10 over -6, which simplifies down to 5 over 3. Next up, so that was, I guess, the first step. Second step here is to go ahead and substitute that into our equation. So using the y coordinates, so the x and y coordinate of point A, that's 5, 14. We're going to do y minus 14 is equal to 5 over 3 x minus 5. Yeah. All right. Next, we can just try and rearrange this and solve for y. And just to show you how you might do that using the CAS calculator, you can use this Action Advanced Solve button over here. Type in y minus 14 is equal to 5 over 3 times x minus 5. You're then going to go solve for y. It spits out this equation here. So it turns out that that is equal to 5 over 3x plus 17 over 5. So y is equal to that. That's the equation of the line AB. All right, so that's part 3. Okay, moving on to part 4. So part 4 is asking us to find the gradient of the line BC and hence justify, is ABCD a rectangle? So let's go ahead and try and do that. So to find the gradient of BC, we're going to use the exact same formula as before, which is rise over run. So this time we're finding the difference between the y coordinate of C and the y coordinate of B divided by the x coordinate of C minus the x coordinate of B. Once again, substituting in the coordinates that we have here, that's the difference between 4 minus, so C is 4, 1, and B is -1, 4. So that's 1 minus 4 divided by 4 minus negative 1. So 1 minus 4 divided by 4 minus negative 1, I believe. So that is negative 3 over 5. Okay, so what we can notice now is that if we were to multiply those two gradients together, AB times BC, that is equal to 5 over 3 times negative 3 over 5, which is equal to negative 1. This is important because this is one of those properties of linear equations that we learned in chapter 2, which tells us that the lines AB and BC are perpendicular to one another. So let's write that down so we can say that AB is perpendicular to BC. That's what this symbol here means. So therefore, AB is perpendicular to BC. Therefore, we can say that, okay, well, the angle ABC must be a 90-degree angle. So the way I've labeled that here is we've got this angle from A to B to C. This angle here must be a 90-degree angle. If that angle is a 90-degree angle, then by a similar sort of reasoning, or it's not a huge conceptual leap, we can see that all of those angles must be 90 degrees because these two lines are parallel to each other, these two lines are parallel to each other. They're all 90-degree angles, which tells us that ABCD is a rectangle, which is what the question wanted us to show. Fantastic. Okay, moving on to question 5. We're trying to find the ratio of the lengths AB to the ratio of the length BC. Okay, so question 5, we have ratio of AB to, what was it? AB to BC. Ratio of AB to BC. Yeah, okay. To BC. Okay. So yeah, the notation I've used here, that absolute value sign, that basically is the same thing as the distance between the 2 points. So the distance between AB, we could write it like that. We could write it like that. It means the exact same thing. So let's try and find the distance between A and B and the distance between B and C, and then put it into a ratio, and then we can answer the question. So the distance between A and B, we need to know the points A and B. So that was these two. So we're going to use the distance between 2 points formula, which is based on Pythagoras' theorem and is the difference between the x coordinates squared plus the difference between the y coordinates squared. Okay, so applying that to these 2 points, we have the difference between the x coordinates, which is negative 1 and 5. So that's negative 1 minus 5 squared, plus the difference between the y coordinates, which is 4 and 14. So that's 4 minus 14 squared. And then we can basically take that, put it into the CAS calculator, and then find what that's equal to. So that's negative 6 squared plus negative 10 squared, which comes out as 2 root 34 in simplified surd form. By the same token, we could try and work out what BC is. So BC, using the same formula, that's going to be the difference between the x coordinates first, so that's 4 and negative 1. So we have 4 minus negative 1 squared, plus the difference between the y coordinates of B and C, so that's 1 minus 4 squared. So 1 minus 4 squared. Okay, let's go ahead and substitute that in to the equation. That is 5 squared plus 3 squared. That comes out as root 34. All right, fantastic. So now let's stick that into the ratio. So we're going to see that the ratio AB to BC is equal to 2 root 34 to root 34. And this is basically a fraction. We've got root 34 up the top and root 34 down the bottom. So this ratio is exactly the same as a 2-to-1 ratio, which is to say, looking at this diagram here, this side length here, AB, is 2 times this side length here, BC. Okay, so that's that question there. So that's part 5. Fantastic. Okay, part 6. Part 6 is asking us to find a point P where, so a point P which has the coordinates A0, which lies on the x-axis. So that's a point here, for example. Such that the area of the triangle ADP is 5 times the area of the triangle BCP. So I'm going to try and use this diagram to explain what that is saying. So the argument here is, let's use a couple of colors. I think before I used green. So let's say we use green to illustrate this first triangle here. So this is the triangle ADP, right? That triangle there. And we've got a secondary triangle. Let's put it in, let's say, purple. That's this one here, okay? And I'm going to call that triangle triangle BCP, okay? And the claim here is that the area of the first triangle is equal to 5 times the area of the second triangle here. And what we need to realize here is that when we're looking at triangles, the way that we're going to be calculating the area of that triangle is by using the height and the base of that triangle. So we need to know something about the height. So I'm going to call this triangle here's height H2, and this triangle's here's height H1. And just note that the way that these heights are drawn is such that that orange line that I've drawn there from P to some point on each of these lines meets that line at a right angle. Okay, so we've got those two formulas there. All right, so if we know that that gives us the equation, this is going to give us the equation, the area of a triangle is half base times height. We are going to see, and yeah, can I copy this? Let's see if I can select it. No, that's not working for me. That's all good. I'll rewrite the same thing down here. So we have the area between those two triangles. The area of ADP is equal to 5 times the area of the triangle BCP. So the area of ADP is 5 times base. So the base of this triangle here is the length from A to D, which we actually found out earlier, times H1. So the height of that particular triangle, that needs to be equal to half, so 5 times the area of BCP, which is the base of that triangle, which, as we can see, the base of the purple triangle is actually BC, and its height is H1. So this one here was H2. How did I call it? Yeah, that's H1 and that's H2. Yeah, H1 and H2. All right, so this is where the magic happens. So what we can see, looking at that diagram up there, is a couple of things. Firstly, because this is a parallelogram, the lengths AD and BC are equal to each other. They're parallel, they have the same length. So because those two things are equal to each other, we can just cancel those out on both sides. And we can also see that there's a factor of a half that appears on both sides of this equation here, which means the following must be true. H2 is equal to 5 times H1. We don't need to worry about the area, we just need to worry about this ratio between the two lengths. So to put that in, again, we can see that this orange line here, H2 is 5 times H1. All right, so from here, I'm going to switch over to Desmos, and then we're going to see how we can approach the rest of this question. So let me just bring this up for you. So here I've put in those 4 points, A, B, C, and D. And I'm also going to label for you that point P. So this is this point somewhere on the x-axis, which is defined by this coordinate A. And we're trying to figure out the coordinates such that those two triangles that we drew before, the area of that green triangle is 5 times the area of the purple triangle just there. So we're trying to find which coordinate A makes that statement true. So the realization that I want us to make is that if we look at those two triangles, we can actually figure out the equations of each of the lines. Just like we did in the earlier question, if we use the point gradient form, we can find the equations of each of those lines that pass through those points, and we can actually draw a parallelogram composed of linear equations, like I've sketched for you here. So you could do this for yourself, use the point gradient form to find each of those equations. What we can realize, and I'm just going to make this, let's fix this up so I can work side by side. What we can realize is that, okay, we now know that the ratio between those two sides is a 5:1 ratio, which is to say that the distance between the green and the purple lines is going to be 4 times the distance from that purple line to that red point P. So that's a 4:1 ratio. So I'll draw that for you over here. That is, let's say this is AD. And then over here, we have BC. So that's 4 times the distance to point P. And in fact, what we could almost consider here is that given that distance there is a 4:1 ratio, it's sort of like we have this like family of curves. So this family of points P, such that all of those points are going to be a 4:1 ratio away from that other point there. So if we were to consider that point P was here, then we would see that there's a 1:4 ratio between the distance from point P to the line BC and the distance from that line BC to D. And the same should be true anywhere along this line. So it'll be true of those 2 points there. That's a 1:4 ratio, and also these 2 points here are also going to be a 1:4 ratio. The important thing that we can notice here is that these two lines, AD and BC, because they're parallel, it's like they're described by a family of curves. So a family of curves such that y is equal to -3x plus something, because the gradient of all of these lines is -3/5. So let me put in that family of curves, and I'm going to label it as an orange line, right? So we've got some orange line such that the ratio between these two side lengths is a 1:4 ratio. So let's suppose that P was at this point here, right? If P was at this point, then that must tell us that the ratio between the orange line and the purple line versus the purple line and the red line, because that's the difference between orange and purple is a fifth of the distance of the purple line to the green line, then that means that this ratio must be a 1:4 ratio. Okay. Now, the beauty of this setup is that we know something about the ratio of the green line to the purple line. We know what their y-intercepts are. So we can see here the y-intercept of the green line is 17, the y-intercept of the purple line is 3.4, which is 17/5, because these are both written in gradient intercept form. Yeah. So we can see, if we get back to this diagram here, that this point here on the y-axis is 17, and this point here on the y-axis is 17/5, which means that the difference between those 2 points is just 17 minus 17.5. So 17 minus 17.5, which is, 17 minus 17 over 5, not 17.5, 68.5, right? So the distance between those 2 points is 68 over 5, okay? And I'm saying that if this ratio is a 1 to 4 ratio, then the ratio of 68.5 to whatever this distance here is must be that same ratio. So if I'm trying to figure out what this is, I need to basically divide by 4 to work out what 1/4 of 68 over 5 is. That should be the same distance as here. So if we were to just take that distance, 68 over 5, and divide that by 4, that's going to give us 17 over 5, right? So that means that this distance here, this vertical distance, is 17 over 5. So getting back to our diagram over here, that's going to tell us that if we want to work out where this orange line should be sitting, we need to start at that purple line. So where is this orange line? We need to start at that purple line here, and we need to translate that line 17 over 5 units down. Now, the purple line happens to have the equation negative 3 over 5x plus 17 over 5. So if we were to translate that 17 over 5 units down, that's basically shifting the y-intercept 17 over 5 units down, we're just going to end up with the equation negative 3 over 5x. Okay, which tells us if this point P lies on, this point P must lie on the x-intercept, then it's not just any point on that line, that orange line there that we're looking for. We're actually after the specific points where that equation, negative 3 over 5x, intersects with the y-axis. And what does that tell us? Well, it tells us that this point here, P, must occur at the coordinates 0, 0. So therefore, we can see that the coordinates must be this one right here, and visually, I guess we can kind of see that that satisfies the condition. We could even test this by using the fact that, okay, well, now that we know that this is in fact 0, 0, we could use the fact that, okay, well, now that forms two isosceles triangles, this green one and this purple one. We now know that they're isosceles triangles. We didn't know that before, so if you use that in your explanation, it wouldn't quite work. But now that we know that they are isosceles triangles, we can use the midpoint of BC as, and this coordinate 0, 0, and the midpoint of AD, and this point 0, 0, to then calculate the area of each of those triangles and just verify that the smaller one is in fact a fifth of the large one. And I'll leave that up to you as an exercise for you to complete. But yeah, now we can see the answer here comes out as P must be equal to 0, 0, or in other words, A is equal to 0. All right. So let me know if you had any other ways of answering each of these questions. That last question is quite challenging. The rest of them should be within the realm of possibility for you. But yeah, hopefully this video helped you. If you have any questions, you can see me in class. Otherwise, I will see you soon. Have a good one.